is how much?
Is the X values.
Would be each of these X values. How long was my interval to start with?
1.
1. It went from 0 to 1. And then I divided it by what?
4.
4. So to find the width, we would have said 1 subtract 0 divided by 4. So the width of each of these rectangles is 1/4. Since we're finding using left endpoints, I use a capital L for that and a little tiny 4, which tells me I am finding the area of 4 rectangles using the left side of the rectangle as the height. Okay, so to find the area of this first rectangle, if I'm using the left side as the height, what would I be plugging into the function to find this height? Left side of the interval. On this interval, what is the left side? 0. So you would need to plug in 0 into your function and then multiply it by the width of that rectangle.
1/4.
Yep. Now let's move on to the second rectangle. We'll go back and find those heights in just a minute. What value would you plug into your function to find the height of this second rectangle since I'm using left endpoints? 1/4. So you need to put 1/4 into your function and multiply it by the width. Now to move on to our third rectangle, which would I be using? 1/2. So you have to input that 1/2 into your function to calculate your height. And then in the last rectangle,
3/4.
you would be inputting 3/4 times 1/4. And this is going to give us which one? An overestimate or an underestimate?
Under.
We're using not the black ink, but the pencil. No, we are using the black ink. You're
That should be
right.
underestimate.
So this will be an underestimate because we're using the black marks with our left endpoints. Yes, ma'am. No, how wide is that rectangle? So the width of each of these rectangles is this. Each rectangle is 1/4 of a space wide. Okay? All right. So what do you get when you input 0 into your function? 0 times 1/4 plus, now what happens when you input 1/4 into your function?
1/8.
1 what?
1.
Oh, yeah.
Yeah, 15.
1/16
Yeah.
times 1/4.
Good job, Lucas.
Now input 1/2 into your function. 1/4
There we go.
times 1/4. Now input 3/4 into your function.
What?
9/16 times 1/4. Could I have factored out that 1/4 at the beginning
You could have.
so I didn't have to write it down every time?
Yeah.
So isn't this the same thing as 1/4 times 0 plus 1/16 plus 1/4 plus 9/16?
Sure.
Okay, so let's get an estimate for that. If you have to use a calculator, you can, but you should also be able to add these.
Oh, like fractions.
Well, what's 9/16 plus 1/16?
Oh, well, 10/16.
And simplify that, what do you get?
5 fours.
5,
Whoa. That was terrible. 5/8.
5/8,
Yeah, I was dividing everything by 4.
That would be 2/4.
and that'd be
2/8.
2/8. Wouldn't this be 2/8
Yeah.
plus 5/8?
Yeah. 7/8.
7/8 times 1/4,
Yes.
It should be 7.
30 seconds.
Oh.
That's kind of cool.
Okay, so this is our underestimate.
I have a question.
Yes,
So if so you say second is 2, like they're 2 seconds, but then 1 second is just 1, and so it'd be like seconds. So wouldn't it be like instead of seconds, it'd be like whatever 1 is for seconds, 1 second?
you're talking about how to say it when 1 is the denominator?
No, like in time, because like you say 1 second, and like what technically it's only 1 tick,
Yeah.
not 2 ticks. In seconds would be 2.
Is this under recording?
Not a fraction like this. You don't say 3 seconds, you say 3 halves. So when our denominator is 2, we say halves to avoid that contradiction there.
Okay.
Okay, let's look at R4. So let's estimate
Like 1
the
second.
area using
You get what
4
I'm saying, right?
rectangles, but this time we're using the right endpoint. Are you okay with going ahead and factoring out the width of each of these, that 1/4?
Yeah, that's fine.
So let's factor out that width, because isn't each one of them having a consistent width of a 1/4?
Yeah.
So each rectangle has that same width of 1/4. Now we need to just go through and find the heights using which end, left or right?
Right.
So we're using the right end. Doesn't it help to label these values?
Yeah.
Okay, so if I'm using the right endpoint, I would be inputting 1/4, and then 1/2, and then 3/4, and then 1.
That's pretty easy, how somebody treats
So then f of 1/4 again was 1/16. F of 1/2 is 1/4. F of 3/4, 9/16. F of 1, 1.
So it'd be 15
So that'd be 15
eighths
eighths
times 1/4.
times 1/4. And is this an upper estimate or a lower estimate?
Upper.
Upper.
This is an upper estimate. This is an overestimate of the true area. Do you remember when we first discussed definite integrals? So change gears. If I just gave you this, remember how we would set up an integral to find the area under this curve? How did we do that in our last chapter? All we did was set it up and we stopped there. What would this be the integral from? 0 to 1 of x squared with respect to,
The root of x.
and then I showed you this just real quickly. What would this integrate to be?
Oh, 1/3 x cubed.
Uh-huh. And remember, we're gonna input values of 1 and 0. So do we have to include the c values? Remember that they would subtract out? We only did this briefly in class one day. You input 1 into this and you get 1/3. You input 0 into this and you get 0. And this gives you the exact area under this curve, 1/3. The exact area is 1/3. Isn't 15 30-seconds bigger than that?
Yeah.
And isn't 7 30-seconds smaller than that?
Yeah.
So this is an overestimate, this is an underestimate. Tomorrow, we make sense of the limit as n approaches infinity of a summation, and all of these rectangles, and this definite integral. So tomorrow, we connect it all together.
With trapezoids?
Not yet,
Dang it.
but we will do it with trapezoids. Wouldn't a trapezoid give you an even better estimate than a rectangle would? So there is also something called a trapezoidal rule, and I will go over that too. AP Board expects me to teach that
So
too.
that's one.
Would you, press stop?
Cut.
Circle